Hey guys, so here is part 3 of the 7.4 day 1 notes. So now what we're going to be doing is talking about how with inverse functions, and we've talked about this already, how if we put them together they can cancel things out. So remember in our last unit we talked about inverse functions. If we did like a composition of functions, then it would always equal x. With inverse functions, remember they are a reflection of each other over the line y equals x. So with logarithms, logs and exponentials are inverses of each other. I would write that, okay? So logs and exponentials are inverses. I'm going to write that probably down here where I have more room. There we go. Okay, please write this down so you know they're inverses of each other. So when we put them together, we can cancel them out. Just like when we ever wanted to undo a square root or a cube root or undo a square or cube, we would take the inverse. That's what we're doing. We're going to do some cancellation here so we can simplify. Okay, so as I said, when we do the composition of functions, remember that we should always have it equal to x. So what happens is that when we have our log or exponential, things can cancel out, and whatever's left is our answer. Okay, so in order to do this, though, we need to make sure that the log or the base on the log and the base on our exponential have to be exactly the same in order to cancel. Okay. So the two bases have to be exactly the same in order to cancel. Okay, let's look at number 1. We have log base 5 of 25 to the x. So our bases here are 5 and 25. Now, are those the same number? No. Remember, we have to have the same base. They have to be the same number. So we're going to do some manipulation here so that they are the same base. So we're going to keep them as 5. So I have 5 and 5. Now, I can't magically just change 25 into 5. What I can do is kind of rewrite this where it's equivalent. So 5 to what power gives us 25? Well, that would be 2. So 5 squared is just another way of saying 25. Now notice on the 25 we have an exponent of x. That didn't magically disappear. Instead, we keep it, but now it's with the 2x. Now notice here that our base on the log and the base on the exponent are exactly the same. Because logs and exponentials are inverses, when we put them together, they cancel each other out. So that whole thing cancels. And so what we are left with is 2x. Okay, let's try number 2. So we have 10 to the log of 4. Ooh, do you notice with that log, what base is that? Well, rewriting this, that will be our common log. So remember, that means it has a base of 10. Okay, so is the base on our exponential and base on our log exactly the same? Yes, they are both 10s. So what happens is that since they're inverses, they cancel each other out. So all we're left with is 4. Okay, let's look at 3. We have 8 to the log base 8 of x power. Okay, are the bases on my exponential and on my log exactly the same? Yes. Because of that, we cancel it out, and all we're left with is x. Okay, I want you to go ahead and pause the video and try 4, 5, 6 on your own. Okay, let's see what you got. So we have log base 2 of 64 to the x. Now, is the base on my log and the base on the exponent exactly the same? No. So we need to do some manipulation so they are. So I'm going to have log base 2 of 2. Now I can't magically change 64 to 2. So to write an equivalent expression, 2 to what power gives us 64? Well, that's going to be 6. So 2 to the 6 It's like saying 64. Now notice there was an x as an exponent to the 64. That can't magically go away. Instead, we're going to multiply it with these 6, so we got to keep it there. Now notice the base on my log and base on the exponent are exactly the same, and because logs and exponentials are inverses, they cancel. So my answer would be 6x. Okay, on number 5, is the base on my log and the base on the exponent exactly the same? Yes, we have log base 7 of 7 to the negative 3x. So since they are exactly the same, they can cancel out, and we're left with negative 3x. Okay, last one, log base 6 of 216 to the x. Is the base on my log and the base on the exponent exactly the same? No. So I need to do some manipulation here. So 6 to what power gives us 216? That's going to be 3. And don't forget the x, because that was an exponent on the 216. And we know 6 to the third is just an equivalent way of writing 216. Okay, so we have the same base on our exponent and log, and since they're inverses, they cancel, so we're left with just 3x. Okay, make sure you guys work on the homework assignment, and if you need any help, make sure you contact me. I'll see you guys later.